Okay. As promised, I'm going to do a few extra problems. If you need a little extra help on the graphing, I'm going to go pretty quick, and I just picked a few from the extra review sheet that I gave you. I know on these, I gave you a graph. On the tests and all the ones that we've been doing will just be a normal, like, right, do your own little graph from there. So if this kind of messes you up, feel free to just take these problems and do them on your own. But I've kind of taught this differently in the past. So I'm just kind of trying to give you a few more practice problems if that's what you need before we go. Before we start, I want to remind you sine and cosine graphs. This should be just a given. We know sine starts its middle and it ends in the middle of my graph. Its second point is the highest and its third point's the lowest, and it goes as high as 1 and as low as -1. And remember, that's what my amplitude is. Amplitude is going to be 1 and my period is 2 pi. That's true for cosine, so I'll go do that in a minute, but cosine and sine's normal amplitude is 1, normal period is 2 pi. So I'm going to connect my points. Nice little curved edge. And when I ask you to graph, this is all I need to see. I need to just see these 5 points. You don't need to go further, even though we know sine waves on and on forever. You don't need to show me that. Let me go remind you about cosine too. I have them separated just because I don't know, that's just what I did last time. Cosine starts the highest point and it ends at the highest point, and its lowest point is the middle. The pi over 2 and 3 pi over 2 just go through the center of the graph, so it kind of looks like a horseshoe. You got a little Colt horseshoe. Very nice. Okay. And again, amplitude here is 1, period here is 2 pi, unless we make changes. Okay. So we've done a lot of examples, so I'm going to move kind of quickly. Feel free to like slow this down or rewatch it again if that helps. I'm going to do a couple amplitude changes, a couple period shifts, and then I'll do a couple combinations. I didn't do any of these on this video, but there's more videos online and there is an answer key for this too. So first thing, amplitude changes is the A, it's my height, the top and the bottom. So if my amplitude is 2, then that means that instead of going to 1 and -1, I go from 2 to -2. Nothing else changes. My other pieces stay the same. My first, middle, and last point are in the center of the graph. My second point is the highest, and my last point's the lowest. We've been doing kind of boundaries, so like you can draw a top and a bottom boundary. I did not move left or right any, so it still goes the full length of the period. So from 0 to 2 pi, and then we go from here. In case this is helpful to anyone, remember our original sine graph looks something like this. So all I essentially did was I just kind of grew it, expanded it out a little bit. So instead of crunching, I just kind of stretched it up a little bit. So that's how I know that that's going on there. My next one, my only change is my amplitude again, but this time my amplitude is 1/2. So that means I'm scrunching it lower together, kind of crashing it down. And my period is still 2 pi. So I'm still going through the middle of my graph on my first, middle, and last point, but instead of going all the way up to 1, I'm only going as high as 1/2 and as low as -1/2. So I'm just kind of shrinking it down. Again, I'm sorry if this is a risk, but just so you can kind of see how it changes from the original, the red that I draw on all of these is our original sine graph. So you can kind of see what the transformations are. If that's hurtful, just skip the red graph that I do at the end so you can kind of see the transformations. Okay, period change is probably one of the harder ones. I think period change and period shift is the hardest thing, so we'll do a couple of those. But period change are just, instead of going 2 pi, you might go smaller than 2 pi, or you might go more than 2 pi. And that's impacted by our B. So in this case, my amplitude is 1 because my A is just 1. It's fine. It didn't change. But my period, instead of being 2 pi, it's going to be 2 pi divided by 2. My period is always 2 pi divided what B is. So that means in this case, my period is pi. So that means instead of going from 0 to 2 pi, I'm going to go from 0 and I'm going to stop at pi. So I need to get my whole sine curve in this little space. What we were doing the other day is we were taking all of our quadrant angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are our 5 important points. And whatever our B was, we would divide by that. So in this case, I can divide by 2 or I can multiply by 1/2. So 0 times 1/2 is 0. Well, pi over 2 times 1/2 is going to be pi over 4. So that's this point right here. It happened to be a nice like grid mark on this graph. If not, you can just make your own point. Pi times 1/2 is going to be pi over 2. 3 pi over 2 times 1/2 is going to be 3 pi over 4, which is this mark right here. And then last, which we've already done this, 2 pi times 1/2 or 2 pi divided by 2 is just pi. So that's how I knew I ended here. If my amplitude is 1, then I'm still just going as high as +1 and as low as -1. And I am going to make sure that my graph is somewhere in that little gray box that I have. My sine graph always looks the same, and I'm kind of focusing on sine, so it's really in your head. First, middle, last point are all in the center of our graph. Second point goes up, fourth point goes down. So it looks something like, that. Again, because I've been doing this on the other ones, this is what the original sine graph looks like. It goes through the middle at 0 pi and 2 pi. It goes highest at pi over 2 and lowest at 3 pi over 2. The difference between the blue graph and my red graph is it just kind of gets crunched closer together. It shrinks in a little bit tighter. So I have less space to do my whole sine graph, so it feels like a little skinnier than what it was. Okay. Now we're going to essentially go opposite. This one says sine of 1/2 pi, or sorry, sine of 1/2 x. We're actually going to have to go all the way to 4 pi. So I'm going to actually extend my graph out because here's about 3 pi and here's about 4 pi. My amplitude is still 1. A is still 1. Period this time is going to be 2 pi divided by 1/2, which is 2 pi times 2 over 1, which is 4 pi. So that's how I knew that my graph needed to go further, because instead of getting everything done in 2 pi, I have until 4 pi to get everything done. So I'm really stretching it out, making it longer. I can still think about my points again. This time my quadrant angles are all going to be multiplied by 2 in order to figure out what my points are. So I know my last point is 4 pi because I've already decided that. That's by my period. Now I'm going to think about 0 times 2, pi over 2 times 2, etc., etc. So I'll just kind of do those one at a time. 0 times 2 is still 0. So that means that's my starting point is at 0. Pi over 2 times 2 is going to be just pi. So I'm going to have a point at 0, a point at pi. You don't have to circle your points on your graph. I'm just proving a point. I'm going to do pi times 2, which is going to be 2 pi. So that's going to be here. And then last thing I need to do is 3 pi over 2 times 2, which gives me 3 pi. You can still do 2 pi times 2, but we should have already done that over here. So that's going to be 4 pi. So my points are 0 pi, 2 pi, 3 pi, 4 pi. After that, I remember that I'm graphing sine. So I need to remember that I'm going as high as +1 and as low as -1. So those are my top and bottom bounds. And then now I have this long skinny box that I have to do my whole sine curve in. So first, middle, last point are all on the middle of my graph. My second point, so at pi, is high. My fourth point at 3 pi is low. So I'm going to just kind of connect the dots right there. I know that's kind of messy. In lieu of what I have been doing, sine would normally look like this. So you can see how the purple graph is really stretched out from the red graph. And if we even zoom out, you see how the blue one is way scrunched in from the red and definitely way scrunched in from the purple. So those are all just kind of shifting, stretching and shrinking along the period, along my x-axis. I think that we're okay with doing both at the same time. I hope, especially after that review. But again, the answers are online. I want to do 1 or 2 where I'm doing a few more changes. So I'm going to do kind of all of these together. This next one has a vertical and a horizontal shift. So I'm not changing my amplitude or period. My amplitude is 1, my period is 2 pi. However, I'm going to go right or left, and I'm going to go up and down. The number inside with X tells me what I'm doing and which direction. This time I'm going to go left pi over 2. And my number on the outside tells me my up and down distance. So I'm going to go up 2. Okay. Normally, my amplitude is 1. So normally I would be at +1, -1, right? However, we're also moving up 2. So that means these 2 points have to go up 2 units. So instead of being at -1, I'm going to go up 1, up 2 to be at +1. And instead of being at +1, I'm going to go up 1, up 2 to be up at +3. So I moved everything up 2 units. And I actually don't need that anymore. Now I'm going to move everything left pi over 2 units. Since my period is the same, I'm using my normal quadrant angles, which are actually these guys out here. 0 pi over 2 pi, 3 pi over 2, 2 pi. So we're going to move all of those to the left pi over 2 units. So I'm going to think about doing, okay, all of my numbers minus pi over 2. So the first one is 0 minus pi over 2. So that's negative pi over 2. So that means this is my first starting point at negative pi over 2. Okay. Now we'll do pi over 2 minus pi over 2. Okay, that's 0. So I'm still going to have a point at 0. Now I have to do pi minus pi over 2, which is like 1 minus a half. So that's just going to be 1/2 or pi over 2. 3 pi over 2 minus 1 pi over 2 is 2 pi over 2 or just pi. And then 2 pi minus pi over 2 is going to be 3 pi over 2. So my last point is actually here at 3 pi over 2. Okay. I'm still graphing sine, so I'm going to go here. My first, middle, and last point are all going to be in the middle of my graph, which is no longer at 0. The middle of my graph is now at 2. It's in the very middle of that box. So the first and the last point are easy to find because they're the edges of my boundary. The middle point is just wherever is exactly in between them. In this case, it's going to be pi over 2. Then my second point goes up and my last point goes down. The reason I draw my bound is so that I go as far left and right as the box and I go as high up and down as the box. So that's why if you think you're too cool for school and don't draw the box, I'd make sure that you're making sure that your sign is as big as possible. Fits the whole space. Okay. We're going to do one more of the sign and then 1 or 2 cosines, and we're going to call it a day. This one, it says all changes. It doesn't have all of them. But I also will not give you all 4 changes on the test. I'll probably give you max 3 things to do, not all 4 when you're doing the graph. So I'm just going to do this example with these 3, excuse me, changes. So the first thing I notice is the 2 means that my amplitude is 2. There's no b, so my period is just going to be 2 pi. I'm going to go to the right pi units. And I'm going to come up 1 unit. I think my graph is going to have to go a little bit farther because if my period, oh, I guess I'll worry about that in a second. Let me do my amplitude first. So amplitude is 2. Instead of being at +2 and -2, which I normally would be at with an amplitude of 2, I'm going to move all of those up 1. So I'm going to take my boundary essentially, and I can just do this notability magic since I'm on here. I'm taking my, oh, that's not at all what I wanted. I'm just taking my bounds, and instead of staying at -2 and 2, I'm going to go up 1 unit. So I'm going to go up to 3 and -1. And you're welcome to keep those other labels on here, but I'm going to erase them to remind myself I don't really need them. Okay. Now my period is 2 pi, so that means I'm using my normal angles, just to note. This one, this one, this one, this one, this one. 0, pi over 2, pi, 3 pi over 2, 2 pi. We should all know this at this point. But I need to go right pi units, so I need to add pi to all of them. Don't be ashamed to do little work off to the side. I'm probably not going to do it here though, because if I do 2 pi plus pi, I'm going to be at 3 pi. So I'm going to preemptively know that my graph is going to go over here a little bit. The one benefit I actually like about having you guys make your own grid is that you can set it up however. So that was one reason that I chose not to do the grids like this year. So since you're doing it on your own paper, you can put that 3 pi wherever you want it. Okay, so my ending point is not going to be 2 pi anymore. It's going to be over at 3 pi. Let me extend those a little bit. All right, and then now I'm going to do the rest of those points. So we did 2 pi. Now I'll do 3 pi over 2. I'll just work backwards this time. 3 pi over 2 plus pi is going to be 5 pi over 2. I'll put that on the graph in a second. Pi plus pi is going to be 2 pi. Okay, that's cool. Knowing that my points are 3 pi, 5 pi over 2, and 2 pi, that means that the only place that 5 pi over 2 is directly in between 2 pi and 3 pi. That's just like where that number goes. Now I'm going to do pi over 2 plus pi, which is going to be 3 pi over 2. And then I'll end with 0 plus pi, which is going to be pi. So I actually have all those other numbers on my graph. If I didn't, I would need to make sure that I wrote pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. I need to see those labels. All right, I'm going to finish by doing a sign graph. So I'm going to graph my first, middle, and last in the very center of the graph. Since I moved up 1, it's not going to be at 0, it's going to be at 1. And then my next point goes as high as possible, and my last point goes as low as possible. Okay. Now, I don't think I did this on the last one, but I was doing it on all the other ones, like what does my original sign graph look like? So my original sign graph would look like this. There are my little points. Oh, shoot. My 3 pi over 2 is not the right point. There we go. So if you see, the red is what sine was, and then the purple is what all of these transformations do. So like the transformations of this equation where my amplitude was 2, my period stayed the same, but I went right and I went up. So like that, I ask for you to explain the transformations and then graph them because I want you to understand what we're doing with the graph. Okay. I've got, I'll do 1 or 2 or 3 of these. I don't know. I'll decide when I'm done. So we'll do a couple cosine. It's the exact same process. You just have to remember cosine's a different graph. So read whatever the problem is and remember whether it's a sine or whether it's cosine and make sure that you're doing the right curve. So the cosine one I have has both an amplitude and a period shift. So we'll do that first. So my change. My amplitude is 1/2 and my period is going to be 2 pi over 2, which is just pi. So I used my B and I have an A. All that means is that instead of going as high as 1/2, or instead of going as high as 1, I'm going as high as 1/2 and as low as -1/2. So I'll put my little boundaries out for that. It's going to be a really tiny box, I think. And instead of taking from 0 to 2 pi to do my graph, I'm only going to go pi. So I'm going to go from 0 to pi. So that means in this little bitty section right here, I have to do my cosine graph. Now, I know that I have little boxes here, but I would have to label my angles. I divided, in order to get my new period, I divided 2 pi by 2. So that means I'm going to take all my quadrant angles and divide them by 2. So 0 divided by 2 or times 1/2. Pi over 2 divided by 2 or times 1/2. Pi divided by 2 or times 1/2. 3 pi over 2 times 1/2 or divided by 2. And then last 2 pi divided by 2 or times 1/2. So I'm going to make sure that my x-axis is labeled as such. I've got 0, I've got pi over 4, I've got pi over 2 already written, 3 pi over 4, and then I'm ending with pi. The last step is to graph my function. I know it's cosine, so it starts high and ends high. Its middle is the very lowest point. Oh, not that low. It's right about here. And then its second and fourth go through the center of the graph. So this is my itty bitty cosine graph. My normal cosine graph would look something like this. So see how from my original red graph, my purple graph shrunk both vertically and horizontally. So it's shrinking all over the place. Okay. For sake of time, I'm just gonna do this last one all together. It's another one of the 3 parts. So I've got an amplitude change, a period shift, and a horizontal, or sorry, period and horizontal, the same vertical shift. I haven't done a lot of period shifts with the period. I'm not sure why this worksheet didn't have as many. You can do those on your own, or if that's the like only thing that's confusing, come see me in office hours. I'll see if I can help you get that all figured out. Okay, so my amplitude is 2. My period is normal, it's 2 pi. I'm going to the left, pi over 2, and I'm going down 3 units. Okay. I always like to start with my amplitude and my going up and down. So my amplitude should be 2 and -2, but I'm going to move both of those points down 3. I can use my notability magic, or I can think, okay, 2 minus 3 is going to be -1, and -2 minus 3 is going to be -5. So I'm going to be here at -1 and at -5. My period shift is to the left, pi over 2. So don't have any change of my period. I'm still using my quadrant angles. I'm still using 0, pi over 2, pi, 3 pi over 2, and 2 pi, but I'm going to minus pi over 2 from all of them. I actually maybe have already done this, so you could always use your past work. I will just do it by hand again, because it's really not that tough. Oh, that's a positive pi over 2. If this part that I'm like doing quickly, you're like, what is even happening? You got to do some fraction work. This is all just minusing fractions. Like this last one, I'm doing 2 minus 1/2. You need to be able to know how to do that. So that means I'm going instead from 0 to 2 pi, I'm going to go from -pi over 2 to 3 pi over 2. And now that I have my box, you just graph your cosine in there. I do my highest point is first and last, my lowest point is down the middle, and then my second and fourth point go through the center of the graph. Normally that's 0, but now since my graph is shifted down, it's 3. Okay. I know that there's a lot more examples I could do, but hopefully this was a few more to kind of clear up a couple others. You can go back and watch all the videos, rewatch the notes and the problems that we did there. I have the answer key for the study guide online, and I have office hours on Monday, but come with a specific question, okay? Hope this helps. Email me if you need anything else. Thank you so much and have a good weekend, guys.